Let's do IXL 7th grade AA.3. Go to Learning, go to 7th grade, then go to AA.3, Area of Triangles and Trapezoids. As always, before we do that, let's go ahead and check out friedmanmath.weebly.com. Make sure that you watch the video. I don't have it posted right now, but by the time you watch this video, it will be up here. You should watch the video that says Area of Basic Shapes. That's going to be in this section right over here, right? The video section. And that explains how to find the areas of rectangles, parallelograms, triangles, and trapezoids. So watch that. And you should also look through the reference pages, which we're going to do right now. So I'm already here on page 12. And we're going to read right now how to find the area of a triangle and how to find the area of a trapezoid, which is also explained in the video. So here TRI stands for triangle and TRAP stands for trapezoid. So to find the area of a triangle, it's just going to be the length times the height divided by 2. That's how I have it on the reference pages, but in the video, instead of using the word length, I used the word base, and I'm going to be doing the same thing in this video. I'm going to be using the word base instead of length, but it doesn't really matter so much what you call it. Something that is important to keep in mind is that the height is always perpendicular to the length, or the height is always perpendicular to the base. So in this triangle over here, you can see that the 4 is making a right angle with this 5 over here. So when I use this formula and I do the length or the base times the height divided by 2, I want to be using the 5 and the 4 because they are perpendicular. I do not want to use the 8. So in this example, we would have 5 times 4 divided by 2, which is 20 divided by 2, which is 10. So we would get 10 square units for the area of this triangle. And where does this formula come from? Well, if you watch the videos, you'll know that, but I'll also explain it again briefly over here, which is that any triangle can be thought of as half of a parallelogram. So this triangle right over here, that is half of this parallelogram. Now the parallelogram, the formula for the area of a parallelogram is just the length times the height. So if the triangle is half of that, then the formula is simply going to be length times height divided by 2, because when we divide something by 2, we're getting half of it. We're taking half of it. All right, now let's talk about the area of a trapezoid. The formula for the area of a trapezoid is going to be the sum of the bases times the height divided by 2. And so for this example here, the sum of the bases, so this would be a base and this would also be a base. So the bases of a trapezoid are parallel to each other. That's how you know that you're looking at the bases. They would be parallel, meaning they're moving in the same direction. So the sum of the bases would be 9 plus 3, which is 12. But we have to take the sum of the bases and we have to multiply that by the height. Now the height here is 4. It's not 5. Remember, the height is defined by being perpendicular to the base. So the 4 here is perpendicular to the 9. The 5 is not. And the 4, by the way, is also perpendicular to the 3. Either one. So we're going to be saying that the 4 is the height. So after we add the two bases, 9 plus 3 is 12. Then we multiply by the height, which is 4. And then we divide all of that by 2. So 12 times 4 is 48. And then when we divide that by 2, we would get 24 square units. And again, where does this formula come from in the first place? I explained that in the video, but I'll also briefly talk about it over here. It comes from the fact that that any trapezoid can be thought of as half of a parallelogram. So this trapezoid over here is half of this parallelogram. I'm not doing a very good job of drawing over that, but the trapezoid is exactly half of the parallelogram. So we have a similar situation which is very similar to the triangle situation, where we said that the area of the triangle is going to be just half of length times height, because the area of a parallelogram is length times height, but a triangle is half of a parallelogram, so it will be length times height divided by 2. Now, over here, why is this formula not exactly the same as this? Because the reasoning is very similar. A trapezoid is half of a parallelogram, just like a triangle is half of a parallelogram. So why is this formula different from this formula? Well, the reason is, and I explain this a little bit better in the video, so please watch the video. But the reason for that is that if I go back to the triangle here, the base of the triangle is exactly the same as the base of the parallelogram. But in this case, for the trapezoid, the base of the trapezoid is not exactly the same as the base of the parallelogram, right? So in order to get the base of the parallelogram, then we would have to take this base, which is the bottom base of the trapezoid, and add this base, which is actually the top of the base of the trapezoid. So this base, this, and this are the same. So when we add the two bases together, then we get the base of the parallelogram. So the parallelogram would be the sum of the two bases of the trapezoid times the height, which is the same for the parallelogram and the trapezoid, divided by 2. Again, I explained that a lot better in the video, so go watch the video if you were confused there. In fact, I think the video was shorter than my explanation here, so it's a better idea for you to just watch the video first. But anywho, these are our two formulas. This is the formula for the triangle. This is the formula for the trapezoid. So let's go ahead and use those to answer these IXL exercises. So, what is the area of this shape here? Well, first let's identify the shape. This shape is a triangle. So we have to use the formula for the area of a triangle, which is length times height, or I'm going to call it base times height, divided by 2. So all I have to do is write that out. The area is equal to the base times the height divided by 2. All right, so the base is 5, right? 5 over here. The height is 4, and we're going to divide that by 2. So the area is equal to all of this. So we have 5 times 4 is 20, and 20 divided by 2 is is that is actually the exact same example that I have over here on the reference page, isn't it? So that's kind of funny. So yeah, so we're going to get 10, this would be square kilometers, right? Because the units for the 5 are 5 kilometers. We have kilometers here. The 4 is also 4 kilometers. So we have kilometers times kilometers would give us kilometers squared, or square kilometers. This 2 here is dimensionless, so that's not going to factor into our unit analysis. So we're just going to get 10 square kilometers as the answer. And you don't really have to do unit analysis yourself because the IXL already does that unit analysis. It tells you that the answer is going to be in square kilometers, but I just like talking about it over there. So we'll put a 10 here. Okay, so let's go ahead and do these quick. So once again, we have another triangle. So the area of a triangle is base times height divided by 2. So the base here is 2 times the height is 3. We're going to divide that by 2. So we're going to get the area is 6 divided by 2, which is 3. And that's going to be square meters, because this was meters and this was meters. So meters times meters is square meters. And we'll put that in here. What is the area of this triangle over here? Okay, so, well, again, that's a triangle. So again, it's just going to be 10 times 7, which is 70, divided by 2, which is 35. Okay, it's giving me another triangle. I wonder if this level is all triangles. This would be 5 times 6 is 30, and 30 divided by 2 is 15. I'm going to press submit one more time, and if it gives me another triangle, okay, here we go, trapezoid. Now let's look at our formula for the area of a trapezoid. So in this case, we have to get the sum of the bases. That means we have to add the two bases together, then multiply by the height, and then divide by 2. So I'm going to say that the area of a trapezoid is base, I'm going to call this base 1, and I'm going to call this base 2. So I would have base 1 plus base 2 times the height divided by 2. So let's plug those in. So base 1 is 8. So we have 8 plus base 2 is 4. So let's put a 4 here. We're going to multiply that by the height, which is 7, and divide the whole thing by 2. So the area is going to be equal to 8 plus 4 is 12. So 12 times 7 divided by 2. 12 times 7 is, 84 divided by 2, which is 42. And that's also going to be square feet. because this is feet, and this is feet, and this is feet. You might look at that and think that it should be feet to the third power, but actually that's wrong because feet plus feet is still feet. If we add the units together, or if we add numbers together where the numbers have the same units, which by the way is the only thing that we can do. You can only add numbers together if the units are the same. Then the units of the result are also the same. So feet plus feet is still feet over here. It's only when we multiply this and this, right? It's because of the multiplication that we get feet squared. So we actually have feet times feet is square feet. Okay, and again, IXL does that for you, so you don't really have to worry about the units so much there, but I still just like to talk about it. Our answer there was 42 square feet. What is the area of this trapezoid? Let's do one more trapezoid problem and then maybe jump to the next level. So again, our formula for the area of a trapezoid is we have to add the two bases, then multiply by the height, then divide by 2. So let's write that out. We have base 1 plus base 2 times the height divided by 2, where we're going to call this base 1. Actually, it doesn't matter which one we call base 1 and which one we call base 2. Because again, when you add them up, the order that you add in doesn't matter because of the commutative property, which works for addition and also multiplication. So it really doesn't matter which one you call base 1 and base 2 because you're just adding them together. And the height is 5. So we have 8 plus 4. Isn't that what we had for the last one? I think so. Times 5. I forgot to multiply by 5. And then divide by 2. So we get that the area is equal to 12, which is 8 plus 4 is 12, times 5. Remember, a dot can also mean multiplication. Divided by 2. So that's going to give us 60 divided by 2. 12 times 5 is 60. And 60 divided by 2 is 30. So we're going to get 30 square yards there. Again, well, okay, I was going to talk about the unit analysis again, but you're probably sick of me doing that, so I'll just type in the answer. 30 square yards. There we go. Okay, so we're getting another problem which is exactly the same. So we're going to jump a level. Okay, so here we have a triangle. So let's go ahead and remind ourselves of the formula for a triangle, which is length times height divided by 2. I'm just going to call it base times height divided by 2. Because honestly, that's what most people call it. So I'll just be, in case you watch another video on triangles or you hear somebody else talking about it, I don't want you to get confused. So I'll just use the same terminology that most other people use, and I'll say base times height. So the area of a triangle is base times height divided by 2. But this time we have been given the area. So we have to plug that in over here, not in here. So that area is 49.8 square feet. I'm just going to go ahead and put the units in here because you may not need to do this for this IXL exercise, but it's good to know how to work with units. So I'm going to put that in. Now that's going to be equal to the base, which is 12 feet, times the height. Now we do not know what the height is. They're calling it S, okay? So even though it looks weird, we're just gonna plug in S for H. We'll say that that's S feet. And then we have to divide by 2. Okay, so what do we have here? How do we solve for S? You know what, that might actually look a little bit confusing, so I'll take these out for now, and I'll put them back in later when we talk about the units. How can we solve for S over here? Well, what we're going to do is first we're going to get rid of this 2, and then we're going to get rid of this 12. So to get rid of this 2, since this is division, we have to multiply. So we are going to multiply both sides by 2. So that cancels over here. And over here, we're going to get, what? We're going to get 99.6. So we have 99.6 equals 12 times S. And then the next thing that we're going to have to do is divide both sides by 12 in order to get rid of this 12 here. So our final answer is going to be S equals, I'm just going to go ahead and use a calculator. I don't mind if you use a calculator because this exercise is not really testing your ability to multiply and divide. It's really testing your ability to find the areas or bases or heights of triangles and trapezoids. So feel free to just use a regular calculator here. So 99.6 divided by 12 is equal to 8.3. So let's put that in over there. All right, let's do another triangle one. Well, okay, well, this time we're looking for the area. Oh, I forgot to talk about the units before. That's okay. That's all right. The area, again, of a triangle is equal to the base times the height divided by 2. We're looking for the area here, so we're going to plug in the base, which is 8.7, and the height, which is 8.5, and then divide by 2. Okay, again, we don't know the area, so we're not plugging these numbers in for A. We're plugging them in for the base and the height, because this is the base and this is the height. Now let's go ahead and do 8.7 times 8.5 divided by 2 gives us 36.975. Do they want us to round to the nearest tenth or hundredth or something? No, so 36.975 square meters. Okay, this problem is like the last one, so I was hoping that they would give me another problem where we have to solve for the base or the height, but I'm going to skip a level here. Okay, this is another problem where they're asking us for the area. You have to read these carefully. So we are told that the base of the triangle is 15 miles. One second. right, sorry about that. I had to go check something. So yeah, they're telling us that the base of the triangle, that's also important to read. So this is a triangle that we're talking about, not a trapezoid. So the base of that triangle is 15 miles, and the height of the triangle is 10 miles, and we are looking for the area. So let's go ahead and write our triangle formula. Area is equal to the base times the height divided by 2. Plug those numbers in. So the base is 15, the height is 10, and divide that by 2. So the area is equal to 15 times 10 is 150 divided by 2, which is equal to 75. And that's going to be square miles. All right, so now be careful because for this one, this is a trapezoid. Make sure you're paying attention to that. Trapezoid, not a triangle. So let's remind ourselves what the formula is for the area of a trapezoid. It's very similar to a triangle, except the first thing that we need to do here in the numerator is take the sum of the bases. That means we add up the two bases. So our area formula for a trapezoid is going to be the sum of the bases. So let's write base 1 plus base 2 times the height divided by 2. So base 1, it really doesn't matter which one of these you call base 1 and which one you call base 2. I'll just go ahead and call this one base 1. A trapezoid has 7 centimeters. Well, that actually the grammar here is not very good. So a trapezoid has a base of 7 centimeters. That would be the proper way to say it. Or you could say a 7 centimeter base. Anyway, let's plug that in for base 1. So we don't know what the area is, so we'll keep the A here. The area is what we're looking for. What is the area? So let's plug in the 7 for base 1, plus we'll plug in the 1.8 for base 2, and we have to multiply that with the height. So it says that the height is 8 centimeters. Now you do have to, and then put that all over 2. You do have to be careful there, because if you mess up the 7 and the 1.8, so for example, if you put the 1.8 here and you put the 7 here, that doesn't really matter. It doesn't matter which one of these you put first and which one you put second. But the height must be outside of the parentheses. The height is what you're multiplying the sum of these by. So even though you can change the order of these two, you cannot change where anything else is. The 8 has to be outside of the parentheses multiplying these things, because it's only the height that gets multiplied with the sum. So now let's go ahead and say we have 7. 7 plus 1.8 is just 8.8. Right? Because 7 is like 7.0. And when we add 8.8, sorry, when we add 1.8, we get 8.8. So we have 8.8 times this other 8, all of that divided by 2. So actually, we could say that 8 divided by 2 is 4, and then you could do 4 times 8.8. Is 35.2. And just to show you that that does work, I'll do it the other way, which I'll do 8.8 times 8 first and then divide by 2, and you'll see that we get the same answer. So 8 35.8 times 8, and then take this answer here and divide that by 2, and we get the same thing we got last time, which is 35.2. So the area there is 35.2 square centimeters. Okay, good. So this is a question that I wanted. You have to be careful again. First of all, it's talking about a triangle. So let's make sure that we're using the formula for a triangle, which is just length times height, or base times height, divided by 2. All right, so we'll write area equals base times height divided by 2. But this time, they give us the area here. The area is 105 square inches. So we're going to plug it in here for A, not for B or H. 105 square inches is equal to, now the height is 14 inches, so let's plug that in for H. So we have 14 here times the base over 2. All right, so we have 105 is equal to, now you could do this a couple of ways. You could multiply both sides by 2. You could multiply both sides by 2, and then your next step would be to divide both sides by 14. But I'm going to do that a different way, because actually, well, you know what? Okay, I will do it that way first, and then I'll do it a different way next, because I think you're probably more familiar with this way. So let's do that first. Let's multiply both sides by 2. So that cancels, and we get, I don't know why I put 105 over here. That should not be there. So 2 times 105 is 210, which is equal to, the 2's canceled, so we have B times 14 over here. Then we divide both sides by 14. We get B equals, you can go ahead and use a calculator for this, so 210 divided by 14 is equal to 15. So that would be our answer there, is 15 just inches, not square inches, because that was the base, it was not the area. So that would be the answer there. And I just wanted to show you that you could actually do that a different way. So starting from this point over here, we could say that 105 is equal to B times 14 divided by 2. But then we could just say that 14 divided by 2, 14 divided by 2 is 7. So we could just rewrite this as 105 is equal to B times 7. And then what we could do is we could divide both sides by 7. The 7's there cancel, and B is equal to, and if I do that, you'll see that again I'll get the same answer. So 105 divided by 7 is equal to 15. Right, so we get the same answer that way also. Just another way of doing it. Okay, same answer here and here. Okay. Let's submit that. All right, so we have fractions here. So let's do a fraction one. So this is a triangle, obviously. So the area of a triangle is going to be the base times the height divided by 2. We are not given the area here. We are given the base, which is 1. the height, which is 1 2/5, and then we take all of that and divide by 2. Now, this part here is actually pretty easy, because anything times 1 is just itself. So 1 2/5 times 1 is still just 1 2/5. Then we need to take that and divide by 2. So we can rewrite this a couple ways to do this, but we could rewrite this mixed number. Remember, multiply the denominator with this whole number in front and then add the numerator. So 5 times 1 is 5, plus 2 is 7. So we would get 7 over 5 over 2. And that's going to be the same thing as 7 over 5 times 2. And if you don't believe me, you can just think of this denominator over here as a fraction, because 2 is the same thing as 2 over 1, right? And then you could just do keep, change, flip. So I'm going to do this over here because I ran out of space. We could do keep, so we'll keep this the same. Change division to multiplication. And flip this 2 over 1, that will become 1 over 2. And then we just multiply the numerators and multiply the denominators. So that would be 7 over 10, which is the same thing that I wrote over here, because 5 times 2 is 10. So we have 7 over 10 there. So if you have a fraction here, and then you're dividing by some number, in this case, this was a whole number that we had before, right? So if you have a fraction, and then you're dividing by a whole number, really what you could do is just take that whole number and multiply it with this denominator, because that's what you're going to end up doing anyway if you use the keep, change, flip strategy. You would just end up multiplying these two numbers in the denominator here. Okay, so then we're done with that problem. So the area would be 7/10 of a square mile. So let's put that over here. Make sure that you are using the / when you put that fraction bar in, not the backslash. You see how these two things are different? Because I don't think IXL gives you credit if you use the wrong one. So make sure you're using the / not the backslash. Oh boy. Okay, so let's find the area of this trapezoid. And in order to do that, we're going to have to be multiplying a whole bunch of mixed numbers together. Okay. Do that over here. So let's remind ourselves that the area of a trapezoid is the sum of the bases times the height divided by 2. So let's write that over here. The area of a trapezoid is base 1 plus base 2 times the height divided by 2. So the area in this case is, let's call this one base 1 and this one base 2. So then we have 10 2/5 plus 6 times the height, which was 8 1/4, all of that divided by 2. Now this part is pretty easy actually. 10 and 2/5 plus 6 is just going to be 16 and 2/5. And then we need to take that and multiply it by 8 and 1/4, and then divide all of that by 2. Now to multiply these things, that is going to be a little bit tougher. We're going to have to turn these into improper fractions first. So we have 5 times 16 and then plus 2. So 5 times 16 is 80. 80 plus 2 is 82. So we're going to get 82 over 5. Don't forget to keep the original denominator. Times, and this one, 4 times 8 is 32. 32 plus 1 is 33. So we're going to get, I'll switch back to blue, 33 over 4. Again, we're keeping the original denominator. And then after we multiply these two things, we're going to have to divide all of that by 2. All right, so let's go ahead and I'm not going to do all of this by hand. I'll just use the calculator for 82 times 33, which is 2,706. So I'm going to get here 2,000. How did this? Okay. What did we say? 2,706 over 20, right? 5 times 4 is 20. And all of that is now divided by 2. Now remember what we said earlier. This is the same thing as 2,706 over 20 times 2. I could just, if I have a fraction here, and then I'm dividing by some whole number. Wait, why did I put a 4 there? I'm sorry. That should be a 2. Oh, now I have to figure out how to go back here. Oh, that's, okay. That's why. Okay, sorry. So if I have a fraction over here and I divide by a whole number, then really the easy way to do that is to just take this whole number here and multiply it by the denominator. And this times this, that's going to be your new denominator. So this is going to be 2,706 over 40, and now we have to do all that. Oh boy. Okay. So let me erase this. Now, unfortunately, the calculator is not going to help me here because the calculator is just going to give me a decimal here, but we want a mixed number over here. So let's go ahead and do this by hand. So we have 2,706 divided by 40. Now, 40 does not go into 2. 40 does not go into 27. Whoops. 0 times 40 is 0. Subtract. We get 27. 40 goes into 270. So let's think about that for a second. Now, when you have a 0 here, you could just imagine, if you have a 0 here and a 0 here, you can just imagine them being gone. So, and you can ask yourself, how many times does 4 go into 27? Well, let's see. 4 times 6 would be 24. 4 times 7 would be 28. That's too much, so 6 is the most. So 40 goes into 270, also 6 times. That's going to give us 240. Then we subtract there, we get 30 here, bring down the 6. So let's see, that's going to be 7. 7 times 40 is 280. And that's going to give us 26, right? Borrow from the 2, that becomes a 10. Borrow from the 10, that becomes a 9. No, what? I'm sorry. Oh, I'm sorry. How long has this video been so far? This has been 45 minutes. I'm getting a little bit tired. I'm sorry about that. No, there's no reason for me to borrow yet because I can just do 6 minus 0 is 6. You did hear me say a few seconds ago that the answer would be 26, so you know that I haven't completely lost my mind. Over here is where we need to borrow, so I can't take 8 away from 0, so I'll borrow from the 3. That becomes a 2. Put a 1 over here. So 10 minus 8 is 2, and 2 minus 2 is 0. So that's just going to be 26. So we'll put the 26 over here over our original divisor, which was 40. And we can reduce that. So let's see, we can divide this and this by 2. And we will get, let's keep the 67. And 26 divided by 2 is 13. 40 divided by 2 is 20. Can we reduce that anymore? No. 13 is a prime number, and 20 is not a multiple of 13. So that's the best we can do there. So the area of this trapezoid is going to be 67 and 13/20. Please tell me I got this right. See, now I know how you guys feel when you work so long on a problem and get it wrong and your smart score goes down, and then you come to class and you complain about it to me. Now I know how you feel. I hope I get that right. Oh, yes. Okay. See, but then it feels good when your smart score goes up, right? Okay, this one is very similar. We have mixed numbers again. The only difference is a triangle, not a trapezoid. So you would use this formula, not this one. So I'm going to go ahead and jump to the next level and see if I get anything different here. Which figure has a greater area? Okay, so for this one, all right, so I'll just do one of these. You know how to find the area of a trapezoid. You know how to find the area of a triangle. So just find the area of this, find the area of this, and see which one is bigger. So I'll just do one here. This one is a triangle. So I'll use the triangle formula, which is just base times height divided by 2. So we're going to get 18 times 12 divided by 2. I'm going to use a little trick here to simplify that. So 12 divided by 2 is 6. So I can say that this is the same as 18 times 6, and that's going to give me 108. So the area of this one is 108. Now the area of the other one, the trapezoid, now we have to use the trapezoid formula, which is similar to a triangle, but we're just adding the two bases first. Okay, so we have, I'm going to put that over here because I know I'm going to run out of space. So we have 13 plus 4.7 times another 13, because the base was 13 and the height also just coincidentally was also 13. We're going to divide all of that by 2. All right, so for this one, we have 13 plus 4.7 is 17.7. We're going to multiply that by 13, and then we're going to divide that by 2. And for that one, go ahead, use a calculator. I'm going to use a calculator for that one. 17.7 times 13 is 230.1 divided by 2 is 115.5. So that was this one over here. So which one is bigger? 115.5 is bigger. So our answer is going to be this one right over there. Okay. Let's see. Am I getting anything different here? I think this is pretty much the same. Again, just find the area of both of these triangles. And then see which one is bigger. Greater means bigger. All right, so I think I'm going to end it there. Hope that was helpful. Have a great night.